In this video, I'm going to talk about electromagnetic theory. The assignment that is given to us, there are many subtopics, but in this video, we are going to mainly focusing more on power electronics, which is about EMC and EMI. So let's start with my teammates' name, which is Ruslianita Rusman, Farah Diana, Farah wahidah, Hanan and our beloved lecturer, which is Dr. El Sheikh Muhammad. So I'm going to brief a little bit more about power electronics. So this is the definition. Power electronics is basically a study of switching electronic circuits in order to control the flow of electrical energy. Power electronics is technology behind switching power supplies, power converters, power inverters, motor drive, and motor soft starters. So, where are the applications of power electronics? In our daily life, we can see the power electronic being used in an regulator, light dimmer, air conditioning that is being used in office, houses, and school too. Next one is automotive and traction. You can see in subways, hybrid electric vehicle, and trolley. The next one, you can see the application also in industry, rolling mills, textile mills, cement mills, and compressor. Sorry. So the lastly is in aerospace industry, which is aircraft, satellites, and space shuttle. So let's move on to our content in this video. The first one is introduction. The second one, we're going to talk about background. The third one is source electromagnetic interference. The target market, discussion, EMI filter application, and lastly the conclusion. So let's start with our introduction first. So this is the difference between EMC and EMI. So what is EMC stand for? EMC is the meaning of electromagnetic compatibility, aka EMC. So the definition of EMC is achieved when a device functions satisfactorily without introducing intolerable disturbance to the electromagnetic environment. And the ability to function intended operating without causing or affect the performance due to intentional EMI, while the electromagnetic interference, which is EMI, is degradation in the performance of a device due to field making up the electromagnetic environment. EMI is adversely affects the performance of electrical/electronic responses or complete operational failure. So the difference is that the EMC is the system that can function without affect the system, and then the EMI is the system that affect the performance of the system. So in the we move on to the next slide, which is EMC will accept any normal interference and won't interfere with other device, while EMI is the normal interference, which is cosmic radiation or thunderstorm. We can see the example of EMC being used in our daily life, which is FM radio crackling when the neighbor drilling holes on his wall. This phenomena we call as GSM song. Or radio clicking when the fluorescent tube starting to light on. While EMI, you can see in your daily life example, which is disturbance in the audio or video signals on radio or television due an aircraft flying at low altitude, and noise on microphone from a cell phone handshaking with communication tower to process a call. Where do EMC and EMI being used? Traffic light, ATM, television, and smartphone, yet you are currently in use. So what is the main purpose of EMC and EMI? In these modern technologies, this system is used to deliver the power for maximum efficiency, to cut costs, and to work in an integrated circuit. So let's move on to our background study, which is power electronic is an application of solid-state electronic to control and conversion of electrical power. It is performed with the help of semiconductor switching device such as diode, thyristor, and transistor. AC-DC converter, or as known as rectifier, is the most typical power electronic device found in any consumer electronics device such as television sets, personal computers, battery charge, and others. Let's talk in depth about power electronics. The studies of power electronics is involving the study of electronic circuit in controlling the flow of electrical energy. Power electronic can be separated into two. Number one is power circuit. Number two is electronic circuit. What is power circuit? Power circuit is convert and control input power from AC or DC type to a controlled AC or DC voltage or current and deliver it to a load, while electronic circuit control the converter by generate the signal for the power circuit and measuring the input and output voltage and current. So we're going to talk about our number 3 content, which is source of electromagnetic interference. This source can be divided into two. Number 1 is natural source of EMI, and number 2 is man-made source of EMI. Natural source of EMI, the example is lightning, while the man-made source is commercial radio and telephone. The classification of EMI can be divided into three: functional, incidental, and natural. What is functional of EMI? Functional of EMI is generate electromagnetic energy from any source. This may create an interference as a normal part of its operation, while incidental generate electromagnetic energy from man-made source. It is not designed specifically to generate electromagnetic energy but still cause interference, while natural of EMI is generate electromagnetic energy that caused by natural phenomena, which is such as electrical storm, rain particles, solar and interstellar radiation. EMI control technique. To control or suppress EMI, the three common means employed in the design process are: number 1, grounding; number 2, shielding; while number 3 is filtering. So let's talk about EMI control technique. To control or suppress EMI, the first design process are grounding. What is grounding? Grounding is the establishment of an electrically conducting path between 2 points to connect electrical and electronic element of a system to one another or to some reference point, which may be designed as the ground. An ideal ground plane is a zero potential, zero impedance body that can be used as a reference for all signal in associated circuitry and to which any undesired current can be transferred for the elimination of its effect. Bonding is the establishment of a low impedance path between two metal surfaces. Grounding is a circuit concept, while bonding denotes the physical implementation of that concept. Bond provide protection from electrical shock, power circuit return path, an antenna ground plane connection and also minimize the potential difference between the device. They have the ability to carry large fault current. So let's move on to the second process, which is shielding. Shielding is to confine radiated energy to a specific region or to prevent radiated energy from entering a specific region. Shield may be in the form of partition and boxed, as well as in the form of cable and connector shield. Shield type include solid, non-solid, and braid that is being used on cable. In all cases, a shield can be characterized by its shielding effectiveness. The shielding effectiveness is defined as in the formula SE equal to 10 log incident power density divided by transmitted power density, where the incident power density is the power density at measuring point before a shield is installed, and the transmitted power is the power density at the same point after the shield is in place. Let's talk about our last process, which is filtering. Filtering is a network of lump or distribute constant resistor, inductor, and capacitors that offers comparatively little opposition to certain frequencies while blocking the passage of other frequencies. Filter provide the means whereby level of conductor interference are substantially reduced. Most significant character of a filter is the insertion loss it provides as function of frequency. Insertion loss can be defined as IL equal to 20 log V2 divided by V1, whereas V1 is output voltage of signal source with filter in the circuit. V2 is the output voltage of the signal source without the use of the filter. Let's move on to electromagnetic compatibility. Electromagnetic compatibility is a branch of electrical science which study with unintentional generation, propagation, and reception. This system can be divided into three. Number one, it does not cause interference with other systems. It is not susceptible to emission from other systems. And lastly, it does not cause interference with itself. Medical grade EMI filter meet current requirement for medical application and protect sensitive medical equipment from damage. The methodology used to prevent EMI are suppress the emission at source point, the best method to control EMI. Number two, make the coupling path as inefficient as possible. Lastly, make the receiver less susceptible to emission.
For target market, target marketing and market segmentation by Susan Ward. It involves breaking a market into segments and then concentrating your marketing efforts on one for a few key segments consisting of the customers whose needs and desires the most closely match the product service offering. Number 2, Power Electronic Industry Analysis by Barry McGrath article. Customers are found in all major industrial activities, wherever electric power must be controlled, and in solar power, wind power, electric cars, smart grids, aerospace, and consumer electronics. And then market research, future MRFR, the demand for energy conservation has increased its scope to electric vehicles, industrial systems, and electronic consumption. In application, power semiconductor can be switched from an insulting to a conducting condition by the application of a control current or voltage. This characteristic allows you to insert the semiconductor device into an electric circuit and switch the power off on and off very quickly, controlling the amount of power that is delivered to a load. Discussion. In a power electronic system, line and EMI filters are important section of a system, different load and utility requirements. Development of active EMI filters in high power converters to suppress EMI noise. The integration of power and electronic circuits is the market demand that intensifies the challenges. By decreasing the dV over dt and di over dt means increasing the switching time, which increases losses. Therefore, it is compromised between losses and EMI to determine the switching time. These are the figure for input filter, line and EMI filter. Switching frequency and PWM modulation should be determined based on ripple magnitude and output voltage, total losses, ambient temperature and thermal resistance between power switches and ambient size and cost of passive filter. Switching time can be chosen considering switching losses. EMI filter application. It is called EMI suppression filters that effective way to protect against the harmful impacts of electromagnetic interference. EMI filters that suppress noise from grid power are also called EMI power line filters. EMI filters are often low-pass filters that sieve out high frequencies while letting lower frequencies pass through. And EMI filters is usually most useful for the electromagnetic noise is 9 kHz to 30 MHz frequency range, which is conducted through the wires. Noise can get emitted from a wire on one side of the EMI filter and then travel to the device by recoupling with the wire on the other side. There is only a small length of conductor between the filter and the source of EMI. Using a filter alone can be sufficient. The example for EMI filters, we have single-phase EMI filters, three-phase EMI filters, IEC in-flat filters, DC EMI filters, inverter EMI filters, medical-grade EMI filters, military EMI filters, tempest filters, telecom EMI filters, custom EMI filters, and PCB filters. EMI filters block different frequency of noise and to meet varying regulation in different industry. Here are a few types of EMI filters in residential and industrial application. The first one is appliance and washing machines. These filters ensure devices meet electromagnetic compatibility regulation and help protect them from EMI damage and that can impact their performance. Number 2, single phase. Single phase EMI filters can also be compatible with fitness equipment and motor controls. Number 3, three-phase. Three-phase EMI filters are for use in high power applications such as industrial machinery and motors, medical equipment, test equipment, and industrial tools. Number 4, military. These reliable EMI filters protect against damage to aerospace and military communication system for secure operation. Lastly, medical grade EMI filters meet current requirements for medical application and protect sensitive medical equipment from damage. Lastly, our conclusion, achieving high efficiency is a main concern and a key factor to save energy, but it's very challenging task as we need to compromise with key factors such as quality and power density. We have the differentiation between dV over dt and the di over dt. Also, the design good magnetic elements such as inductor, transformers, and electric machine with low capacitance couplings. Lastly, design a good layout for power circuits with low stray inductance. Thank you. Peace. Love.